SOLIDWORKS has many flexible and powerful workflows when working with third-party design data. 3D Interconnect streamlines collaboration with your customers and supply chain, regardless of which CAD tools they are using. It also allows you to leverage any existing legacy design data created in a variety of CAD formats. 3D Interconnect is much more than just file translation. In fact, it virtually bypasses the entire translation process and allows you to work with CAD data from a variety of sources as though they were native SOLIDWORKS files. It's also intelligent and understands when third-party CAD data is changed within its native design environment. By honouring face and edge IDs, changes to these files are like other changes you would make in SOLIDWORKS. Let's take a look at 3 different workflows to show just how flexible working with third-party CAD data is with 3D Interconnect in SOLIDWORKS. The first workflow focuses on using 3D files in a SOLIDWORKS assembly as if they were just another SOLIDWORKS file, and is probably the most commonly used method of leveraging 3D Interconnect. In this case, a battery pack assembly was designed in Autodesk Inventor, and we need to incorporate it into the Myomo control module, designed in SOLIDWORKS. This could have been designed by a vendor, or possibly a legacy design created in Autodesk Inventor. The file is inserted just like any other SOLIDWORKS component. No translational steps are necessary. All of the geometry is there, not just a representation. Looking at the feature manager tree, we can also see the entire assembly structure is available as well, though notice the icons are slightly different. These icons signify that the component is referencing the original Inventor CAD data. We can use this assembly like any other SOLIDWORKS assembly, mating it into place using the provided reference planes. But because we have all of the 3D geometry, we can mate it to any surface of the components, just like you would with any other SOLIDWORKS file, allowing you to work the way you expect. We've also incorporated some design intent into this retaining bracket. Notice as we mate the back face of the bracket that the countersink holes and rivets along the side move as well. This is important as we've established some design intent here that ultimately references back to our Autodesk Inventor assembly. Now that the design is in place, let's look at how 3D Interconnect handles changes that take place to the native CAD geometry. Within Autodesk Inventor, we've made several changes to both the parts and the assemblies. You can see that not only are the batteries longer and much larger in diameter, the housing has also changed, now only including 6 batteries, and much more rounded to contain their larger size. To simulate the change without Inventor, we're simply going to overwrite the existing files with the new version. When we go back to SOLIDWORKS and perform a rebuild, you'll notice there's now a small refresh icon on the assembly, letting us know there's been a change in the native CAD files. To update the models, all we need to do is right-click on the assembly and choose Update Model. SOLIDWORKS then updates the assembly, as well as all of its child components. More importantly, notice that all of our mates in the assembly update properly, and the countersink holes and rivets move accordingly, honouring the design intent we established. Let's take a look at another example, directly opening a file and using it like a derived or base part. In this case, we will be working with a pulley designed in PTC Creo by a vendor. We will need to add some of our own features that are added after you receive the actual part, in this case a keyway and a hard stop slot. We will show how 3D Interconnect handles changes within this scenario and also how it handles PTC Creo versioned files. This time, instead of inserting a component, we're going to open one directly. Notice that the file has a unique suffix of .1. This is how PTC handles revision changes and will come into play in a moment. Let's just open the file. Notice this time that the top level is an actual SOLIDWORKS part file. However, instead of a traditional imported geometry feature, we get a base or derived part. It is the same unique icon as before, letting us know that it's referencing the native CAD data. In this example, I'll just add a couple of library features to quickly place both a keyway and a slot on the inside surface of the pulley. The important thing to note here is that I'm dropping these onto faces of the part and referencing an edge in both cases, both things that may have caused challenges in using fully translated geometry. Let's add this pulley to our control module assembly by simply dragging and dropping it into place. As we do so, we can clearly see that the slot doesn't line up properly with the hard stop in our design. At this point, we may need to call the vendor and have them make changes in the native CAD tool. In the case of Creo, however, instead of just overwriting the existing file, we will often be provided with a .2 or similar versioned file. When we return to SOLIDWORKS and perform a rebuild, like before, you may notice there's a refresh icon on the derived part in the Feature Manager. Right-click and choose Update Model. In this scenario, we have features that reference the native CAD data, and like before, they update with no errors. The same is true when we switch back to the assembly. This means we can bypass the lengthy import and repair process completely and focus on our designs. For our last scenario, we're going to take a look at how to break the link to the original CAD data and work with the files in a mixed environment. This may be to add your own features to an assembly component, or to do more elaborate work, like perform FeatureWorks recognition on a specific component. In this case, we're going to import another assembly, this time from Siemens Solid Edge. The file in this scenario has come from an online vendor, and we don't have the luxury of making changes to the native data in its original design tool. As you can see, however, there's a hole that's not properly lined up. In this example, we want to move the hole so we can have our own adapter plate made for this circumstance. This is a case where you may want to break the link to select components and make your own parts and assemblies. To do this, you simply need to right-click on the assembly and choose Break Link. In the feature tree, you can see doing this has made a copy, utilising a virtual component, which you can save externally if you wish. If we open this assembly, we can see that it still references the native components that it's comprised of. For this example, we also want to break the link to the adapter plate. When we choose Break Link on this component, however, you'll notice that it now resembles a traditionally imported file in SOLIDWORKS being comprised solely of an imported feature. With our part now a standard imported SOLIDWORKS component, we can make changes to this part using powerful SOLIDWORKS direct editing tools. In this example, I'm going to use FeatureWorks Automatic Feature Recognition to turn this hole into a SOLIDWORKS Hole Wizard feature. The centre of this hole isn't properly located, however, so we'll return to the assembly where we can edit the sketch and properly locate our hole concentric to the existing hole in our design. So I've shown 3 different ways to interact with third-party CAD data in SOLIDWORKS. 3D Interconnect provides extremely powerful ways to work with your supply chain, customers and files you download from the internet, virtually removing the concept of file translation. More importantly, 3D files from third-party design tools are intelligently monitored to make sure they are propagated properly, just like any other SOLIDWORKS file.